This is a short demo of the contribution of European University Cyprus at the MedSecurance project. Our task was to develop three tools related to network recommendations for IoT devices. The first tool is the risk assessment tool. In this tool, the user is able to fill provide some inputs for different IoT protocols. In our case, we are supporting Wi-Fi, Bluetooth, GSM, and LoRaWAN, and also provide some information related to the devices that are attached to the different networks. In this case, in my example, I have 5 devices that are utilizing Wi-Fi, and I already pre-filled a Wi-Fi risk assessment wizard for you. If I click on the wizard, we can see the different fields that the user needs to provide. Intentionally, we leave those Boolean options unchecked to get some recommendations. We need to provide the different access points that comprise the network, any hardware failures that we have, and also if we have already run the TVRA tool and we receive the output, we can upload it as well to the tool to aggregate and provide us at the end some recommendations about the TVRA analysis. By clicking the finish button, we get 4 different categories of recommendations. The first one is mitigations. The initial number at the beginning is the weight of the recommendation, with 5 being the most important recommendations, going all the way down to weight 1. And of course, we provide the appropriate coloring to help the user identify the important ones. Same goes for safe configuration, protocol replacements, if the devices are supporting other protocols apart from Wi-Fi that we are testing now. Also, the tool allows the user to assign some configuration options for different attributes of the system. For example, the lifetime in years that we are expecting the network to be. In this case is 24 years. Of course, we can alter it here, and then the tool will suggest us to update our network if it's more than 5 years old. And of course, for each different network protocols, we can customize those variables. The next tool is the intrusion detection system. Currently, the tool is supporting the analysis of network traces in the form of pickup files, and is using 2 different AI models. The first one is responsible to analyze the initial trace and try to see if there is any kind of attack. And if the first model identifies an attack, then we run a second model that is trying to identify the type of the attack that it was detected on the network trace. Let me give it a try. First, I uploaded the pickup file, and then I will initiate the process. The tool now is going to generate some features from the raw network trace file and then parse it to the different AI models. In this case, we have an attack, and the system is going to send an email to the network administrator. We have the source destination of the MAC address of the communication traces. The third column defines if we have an attack or not. The fourth one provides the probability of the attack detection. And finally, if we have an attack, then the last column will provide us with the type of the attack. In this case, we see that the web attack has probability 1 and is also defined here. Lastly, the last tool is the monitor matrix tool. Basically, this tool is running on the network that we want to analyze, and is checking to see if the devices that are attached to the network are actually defined in the device manager. In this case, we don't have them defined, so we have them as unnamed. In this case, for for all of those unnamed devices, the system will inform the network administrator that we have devices that are not supposed to be attached to the network. The other functionality is that for the devices that the tool can detect on the network, it can analyze the traffic that they generate. And this will allow the users, if we go to the overview, to see where the traffic is going. In our case, because we are running the tool locally, we only see the containers that we have in our deployment, and also the traffic is between the devices internally in our network. In case that we deploy it in a real scenario, we'll see the domain names that the IoMT devices are sending data to, or the IP addresses, and also we can geolocate those domains and IP addresses and provide a list of countries that the data are landing to.